So in this video, I'll be doing a crash course on trigonometric substitution or trig sub. And hopefully the way I show you is faster than what most people teach you, I should say. Whether you're watching this because you're looking at my UCI Math Tutor to Be playlist or you're from somewhere else, hopefully the technique I'm showing will save you a few steps that they typically don't teach you, okay? So I'm going to go through 3 examples to show you the trick, okay? So first one, we have this integral of dx over x squared plus 16, okay? So here, at least at UCI, they tell you to memorize, sub in when it's something squared plus something squared, the x squared plus something squared, then sub in x is a tangent theta, something like that. I don't remember the rules because I don't memorize them, and I suggest you don't memorize them either for the purpose of quickly solving the problems, okay? To understand where they're coming from, you can try to memorize them. Or if you understand them, you don't have to memorize, actually. I don't know what I'm saying. Okay, regardless. So I will tell you to sub a triangle first, okay? So let's do it on the side over here. We have some right triangle with some angle theta. Let's review the Pythagorean theorem very quickly. Pythagorean theorem, if our hypotenuse is c squared is a squared plus b squared. So if we have a hypotenuse, it'll be side squared plus the other side squared. Versus if we have one of the sides, let's say a, it would be hypotenuse squared minus the other side squared. Okay, so this is the form. My hypotenuse will be sum of 2 terms. If it's a side, it'll be hypotenuse minus the other side, okay? So what do we have over here? We have sum of 2 terms. So one of them will be x, so we can write this as x. The other one will be square root of 16, which is 4, okay? And if we do, the hypotenuse is just this guy, this whole square root, x squared plus 16, okay? So if you do the Pythagorean theorem, x squared plus 4 squared is this guy squared, so that makes sense. That works out, okay? So we sub a triangle like this. By the way, if you set this side as x, this side's 4, you'll be okay also. You'll just get a little bit different trig relations, but you'll still get the same answer, okay? I won't go into that in this video, but just want to give you a heads up, okay? I prefer it to sub this way. I'll show you in a bit. So we want to sub everything in this integrand in terms of theta. So how do we do that? We need to get x first in order to get dx, and then we need to get the square root term also. Okay, so let's do x first. How do we get x from this triangle? We know that tangent theta is x over 4. Okay, so 4 tangent theta is equal to x. And this should be what they tell you to sub, that a tangent theta thing. Okay, we get dx, that'll be 4 secant squared theta d theta would be dx, okay? And then they go tell you to sub in right here. So you have to plug in x as 4 tangent theta, you'll get 16 tangent squared plus 16, and then after you do some algebra, you get that is 16 secant squared. So if you square root that, that'll be 4 secants, okay? That's lots of steps. We can actually sub it in directly from this triangle. So I don't know why they don't teach you to do that, okay? So how do we get the square root term in terms of theta? Well, we know that secant theta is square root term over 4. So if you're not familiar with secant, we can first do cosine. Cosine is 4 over the square root term. Okay, so secant is just the inverse. So secant is square root over 4. So let me write that. Secant theta is square root term. So x squared plus 16 over 4. Okay, so we have 4 secant theta is square root x squared plus 16. That's what I just said earlier. 4 secant theta. So you just saved yourself a bunch of steps when you can just plug it in from the triangle right away, okay? So we write this integral as everything in terms of theta. So dx we said was right here, 4 secant squared. Okay, and then the square root term we said was 4 secant theta. Okay, this is an easy integral now. We can simplify to secant theta d theta. Much easier to evaluate, okay? What's this? That is, this you should memorize. It's just ln of secant theta plus tangent theta plus c. We have to back substitute. So at this point, you might have had to draw the triangle anyway. You draw in the beginning, so you have everything already. Secant theta, you can use a triangle, or we also defined it here. But let's just use a triangle. It's square root term over 4. Okay. Tangent theta is x over 4 plus c. And that is our answer. Okay. So it's actually not bad at all. Especially if you sub everything with your triangle. Use your triangle to substitute everything, I should say. Okay. So as earlier, I was saying that if you flip the sides, so if you put 4 over here and x over here, you would get cotangent theta is x over 4 instead as your substitution. So the trig relations will look a little different, but in the end, you should still get the same answer. Okay, so I'll let you try that on your own. This is a crash course. Next one. This one, let's set up a triangle first. So for these trig subproblems, always get in the habit of setting up a triangle first. This is my tip for you. We have a something squared minus something squared, so we know that x is the hypotenuse. Okay? We know that 3 is one of the sides. Okay? And then we have square root x squared minus 9 is the other side. Okay? Again, if you flip these two sides, it won't matter. You'll get a different trig relation. So how do we get everything in this integrand in terms of theta? We need an x. To get x cubed, we need dx, and then we need the square root term. So how do we get x from here? Secant theta is x over 3. So 3 secant theta is x. 3 secant theta tangent theta d theta is dx. Okay? And then we need the square root term. What is that? Tangent theta is square root term over 3. So 3 tangent theta is square root term. Okay? As I said, if you flip the sides, that'll be okay. It'll be 3 cosecant theta is equal to x. I'm more comfortable taking derivatives and integrals of secants and tangents instead of cosecants and cotangents. So that's why I prefer it to set up like this. If you flip the sides and you see that 3 cosecant theta is x, then you just flip the sides to get 3 secant theta instead, okay? If you're more comfortable with secants. If you're comfortable with cosecant and cotangents, great. Okay. So let's substitute everything in this integrand in terms of theta. X squared minus 9, that is 3 tangent theta. Dx is 3 secant theta. Tangent theta. D theta over x cubed. We have x is 3 secant theta. So x cubed would be 3 cubed, which is 27 secant cubed theta. Okay? How do we simplify this? This 3 and this 3 against this one, we will get a third. So we can move that out. Okay? We have this secant and this secant cubed, so this would reduce to a power of 2. Whoops, you can't see that. 2, there we go. Hopefully that's visible on the camera. And then we have tangent squared on top. So we have tangent squared theta over secant squared theta d theta, okay? So this is where you have to be good with your trig integrals to solve the remainder of this. That's the remainder of most trigs, I believe, because it's in the name. You're substituting with the trigonometric function, so then you have to be good with trig integrals. So how do we solve this? There's probably multiple ways. Like, for example, you could change everything in terms of sines and cosines, if you're more comfortable with that. I see that we can simply just do what I would prefer to do, at least. We know that 1 plus tangent squared theta is secant squared theta. So tangent squared theta is secant squared minus 1. So we can write it like this. Okay? And that I would write this as integral of 1 minus 1 over secant squared. What's 1 over secant squared? That's the same thing as cosine squared. d theta. This is just sine squared. Okay, we know how to solve this guy. That's with the half angle formula. So we get 1/6 integral of 1 minus cosine 2 theta d theta. Okay, we keep going. This we know how to integrate. That'll be a 6 times theta minus half sine 2 theta plus c. Okay? We have to back substitute. We can get theta from a triangle. We can use any of the arc trig functions. We could just use also just secant since we defined it here. So arc secant of x over 3 would work. Okay? But again, you can use any of the arc trig functions, that's fine. How about sine of 2 theta? We have theta, but we want sine 2 theta. Well, we can use another trig identity. This is where, again, solving trig integrals, knowing how to do that is important. 2 sine theta, sine of 2 theta is 2 sine theta cosine theta. Okay, we can use this trig identity to help us out. Okay, so we can say this is 6. We said theta was arc secant of x over 3. Okay, minus half times 2 times sine theta cosine theta. Sine theta is, let me shift this down a little bit. Sine theta is square root term over x. Cosine theta is just 3 over x. Okay? So we can rewrite this as a 6 arc secant x over 3. These would cancel. We have a 3 there and then a 6 there. If we distribute that, so there's a minus there. 3 and a 6, that'll be half. And then we get square root x squared minus 9. That's this. Divided by x squared. Plus c. I forgot plus c up here. Okay? So this should be your answer. You can double check my math if I did anything wrong, but the idea was draw the triangle, make the trigonometric substitution, and then I'll just show you how to solve the trig integral. Tangent squared, we know that is with the Pythagorean identity, that's secant squared minus 1. So then we can break this fraction up into secant squared over secant squared, which is 1, minus 1 over secant squared, that's cosine squared. This is sine squared, use the half angle formula, then we know how to integrate. And then sine 2 theta is 2 sine theta cosine theta. So we use lots of identities here. Okay. Okay, let me do one more problem. Okay, so notice we subbed a tangent, a secant. This one, I purposely chose it that it's a sine, if I remember correctly. I really don't remember those rules. They're too complicated to remember, honestly. Just draw the triangle, okay? This is a definite angle, so. Okay, I don't know where exactly I cut off in the previous video. I'll edit it afterward, but we were working on this problem. We're about to start this problem. Integral from 0 to 1, x cubed square root 1 minus x squared dx, okay? So as always, set up your triangle first. Okay? We have something squared minus something squared, so we know that 1 has to be the hypotenuse, x has to be one of the sides, square root 1 minus x squared has to be the last side. Okay, so I'm going to quicker in this one. We want to sub everything in this integrand in terms of theta, so we know that sine theta is x over 1, so x is sine theta, dx would be cosine theta, d theta. And then the square root term, we know that cosine theta is square root term over 1, so square root 1 minus x squared would be cosine theta. Okay. Oh, we have to switch our limits of integration because we made a substitution. Okay. So when x is 0, what is theta? Sine theta is equal to 0. So what is theta? Theta would be 0. How about x is 1? When x is 1, sine theta is equal to 1. At what theta does that happen? Theta is pi over 2. Okay. We sub in x cubed as sine cubed theta. Square root term is cosine theta. Dx is also cosine theta to d theta. Okay? So we have integral from 0 to pi over 2 sine cubed cosine squared d theta. Okay? Remember how to solve this type of trigonal? We have odd power assigned, so we save a factor. Get sine squared theta, cosine squared theta, sine theta, d theta. So the goal is we want our du to be something, some signature of sine theta, d theta. So meaning u would have to be cosine. So we want to change everything here in terms of cosine. That would be 1 minus cosine squared theta times cosine squared theta times sine theta d theta. Now we make a substitution. U would be cosine theta. Du is minus sine theta d theta. Okay? So, we made another substitution. We had to change the limits of integration once again. When theta is 0, what is u? U would be 1. When theta is pi over 2, u would be 0. So integral from 1 to 0 of 1 minus u squared du with the minus sign in front, because it'll be sine theta is minus du. Okay, so that does not look like a minus sign, but there's a minus sign there. Okay, we can make it look nicer. We flip the limits of integration and put a minus sign outside. There's already a minus sign there, so we make it positive. We can also distribute this. That'll be u squared minus u to the 4th du. Okay, and then we know how to integrate this. That's just u cubed over 3 minus u to the 5th over 5. Evaluate from 0 to 1. So that's why it benefits to change the limits of integration, because you don't have to change it back substitute twice in this case. Okay, we get what? We get a third minus a fifth. And I believe that's your answer. As simple as that. Okay, so hopefully this video gave you a shortcut to save some steps on trig sub. For example, in this case, if you just directly sub in from here like most people teach you, you still have to do the extra step. This one's not too bad. 1 minus sine squared, that's cosine squared. Under the square root, that will just be sine. Oh, sorry. I said 1 minus sine squared, so that will be cosine squared, so the square root is cosine. Yep, there you go. I got lost because I saw the sign. Okay? So you just save yourself a few steps. Potentially a few steps, okay? You just sub it from the triangle. Okay? So that's it for this video. Hopefully it did help you out. If it did, please hit that like button and please subscribe to the channel to see more, to get notified if I release some more crash courses, which I most likely will.